Aloha, this is 4.3 guided notes, and today we're going to be talking about solving a system of equations by elimination. Now, previous to this, we talked about solving a system of equations by graphing and also solving a system of equations by substitution. And this is going to be very similar to substitution, but we're just going to, the first couple steps will be different. Okay, so first off, the word eliminate means to get rid of. And our goal of using elimination is to get rid of one whole set of variables. So we can see that we have two variables in every equation. Usually it's going to be x and y. And in order to solve for these or solve the system, we just need to get rid of one variable. Now, the process of doing that is number one, we are going to manipulate an equation to create an opposite, and I'll explain that in a second. Number two, we're going to eliminate the variable. Number three, we're going to solve for the other variable. And number four, we're going to plug into, or we're going to take the variable we just solved, plug it into the other equation or an original equation, and solve for that second variable. And so step four is something that we already did with substitution. Okay, here we go. Our first system is x plus y equals 8 and x minus y equals negative 2. I can see that I have two x's that are the same variable and the same value. This is what we call same because they're both the same value. X, positive x, they are the same. For the y's, this is what we call an opposite because we have a positive y and a negative y. So having those two different values or opposite values, we call this an opposite. When we have a set of opposites, we can then eliminate that variable because plus y and negative y would equal to 0, and so it's going to eliminate to become 0. And anything left, we're going to add downward. So x plus x equals 2x, and 8 minus 2 equals 6. Again, let me go one more time. I found my opposite, positive and negative, of the same variable, same value, opposite values. I eliminated that variable, so that's step 2. And what's left is 2x equals negative 6, because x plus x is 2x, 8 minus 2 is 6. So we're just going to solve for this variable, and I know that I can divide both sides by 2, and I'm going to get x equals 3. And now I'm going to take this variable that I already solved for and plug it back into one of these two original equations. So either one, it doesn't matter which one you use, you'll get the same answer. So I'm going to use the top equation, x plus y equals 8. I'm going to take my 3, I'm going to plug it back into the x, and I'm going to solve. So I know that in order to get y by itself, I need to get rid of this positive 3, so minus 3. But whatever I do to one side, I have to do to the other. 8 minus 3 is 5, and what's left here is just the y. So the solution is going to be ordered pair 3, 5, or x equals 3, y equals positive 5. Okay, looking at my second set of systems of equations, I can see that the 2's are the same, but the 3's are opposite. So I'm going to eliminate my x's. And what's left here? 4y equals negative 4, because 2y plus 2y equals 4y, and 8 minus 12 is negative 4. I'm going to solve for that y variable. Divide by positive 4, divide by positive 4, y equals negative 1. And then I'm going to do step 4 and plug y equals negative 1 back into either equation, either top or bottom. I'm going to use the top. and y equals -1. So I'm going to plug this one right into that y. So I'll get 3x plus 2 times -1 equals 8. 2 times -1, it equals to -2. And I'm going to solve the equation. I'm going to get rid of the constant, which is plus 2 plus 2. And then I'm going to get rid of the coefficient by dividing by 3. So 8 plus 2 is 10. 10 divided by 3 is 10 over 3, or 3.3. And we're going to leave the answer as is. Okay, last system. 2x and -2x. We also have -5y and +5y. And we can see that we have two different sets of opposites. And when this happens, we're going to do the same. We're going to eliminate, but we can actually eliminate both. When we eliminate both variables, we're going to solve downwards. And this all equals to 0 because there's no value there, so it's going to be 0. And 7 minus 7 is also 0. As I look at that equation, 0 equals 0, I know that it's true. And this would indicate that the lines that we're working with are the same lines and that there are infinitely many solutions. Infinitely many solutions. Again, the reason why is because 0 in fact does equal 0, and it's true. Okay, the next one is x plus y equals 8 and x minus 4y equals -2. As I'm looking at this, I can see that I have same, but I don't have an opposite because this is just y and this is -4y. And so when this happens, you need to create an opposite, and we do that by manipulating the equation. Now I can look at this and say the opposite of x is -x. The opposite of -4y is +4y. And the opposite of -2 is +2. I can change the sign of the x so that we have opposites here. But remember that if you change the sign of one, you have to change the sign of all of them. So what do I get? I get -x, +4y, +2. And now I can eliminate because I have opposites right here. I have a +x and a -x. That eliminates itself. And what's left is 5y equals 10. Okay, we're going to solve for y. We're going to divide each side by 5, and we're going to get y equals 2. I'm going to take that 2, plug it back into either of the equations. I'm just going to use the top equation because it's smaller numbers and all positive. And so 2 goes into the y. I'm going to minus 2 to both sides, and I'm going to get x equals 6. So my answer here is ordered pair 6, 2. Okay, next, our middle equation. We have 2x plus 4y equals 10. 2x plus 2y equals 6. I can see that I have a same. And since I have a same and no opposite, I need to create my opposite. And I'm just going to say we're going to change the sign of this bottom 2 to -2 so that cancels it out. So if I change the sign of one, I have to change the sign of all of them. So we're going to make it a -2, -2, and -6. And here's my opposite. I can eliminate it. And what's left here is 4y minus 2y is 2y. 10 minus 6 is 4. To get y by itself, or solve for y, I'm going to divide each side by 2. And I'm going to get y equals 2. Step 4, we take our y equals 2, plug it back into one of the equations. I'm going to use the top equation. And as you can see, 2x plus 4y equals 10. I'm going to take my 2, plug it into the y, and solve. X equals 1. So my answer here is x equals 1, y equals 2, or the ordered pair 1, comma 2. Okay, in our third example, we can see that we have sames. So again, I'm going to multiply it all by -1, or if I change the sign of 1, I have to change the sign of all. So this x becomes -x, 2y becomes -2y, and positive 3 becomes -3. And here I've created an opposite. I'm going to eliminate it. And we can draw our add-in line and add downward. 3x minus x is 2x. 7 minus 3 is 4. I'm going to divide both sides by 2, and x equals positive 2. Okay, we do need to solve the other equation. So I'm going to take my 2, plug it back into, I'm plugging it back into the bottom. Remember that this was changed, and we need to use the original equation, which was positive x, positive 2y, and positive 3. So I'm going to take my 2, plug it back into the original equation, work itself out, and y equals 1/2. Okay, let's move on to the next one. So it's just going to get a little harder, but not too bad. We can see that we don't have sames and we don't have opposites. So again, the object is to take one of our equations and manipulate the equation so that we do have an opposite. And it's always easiest to look at variables that don't have anything there. And I'm going to focus in on this 2 here. The opposite of positive 2y is negative 2y. And I know that if I multiply this by -2, then I will be able to get a set that eliminates itself, or an opposite set. So remember that if we multiply it by -2, we have to multiply everything by -2. So -2 times 3x is -6x. -2 times y is -2y. And -2 times 7 is -14. Okay, because we've created an opposite, I'm going to completely ignore this top equation because I created my new equation down here. And I'm going to use the y's to eliminate. What's left here? -5 minus equals -10. I'm going to divide by -5, divide by -5, x equals 2. Okay, you do need to go back in and solve for the other variable, but because of time, I'm not going to. I'm just going to leave it as this, but just know that this is only up to step 3. I have not done step 4. Okay, let's look at this middle, and the object is to look at this and say, okay, what's the easiest way to make something look like the other but the opposite? And I know that if I multiplied 3 by -2, I would get -6. And this would be positive 6y, and I could get -6y. So if I multiply the whole thing by -2, because if I multiply this by -2, if I multiply one of them, you have to multiply all of them. So -2 times 2x becomes -4x, -6y, positive 10. -4x, -6y, positive 10. Okay, now I have my opposite. And I'm going to add downward. 5x minus 4x is 1x. -8 plus 10 is positive 2. And I know that because this is a 1, I can just rewrite it as x equals 2. Again, this is only up to step 3. And I should really be solving for the other variable, but again, we're not going to. We're just going to keep moving on. Okay, here we go. I could say that if I multiply this by -3, I get -6, and that would eliminate. But also here, if I multiply this by -3, I could also get the opposite, which is, sorry, -3. So +3 would be what's there, and we would manipulate this to become -3. So I'm going to multiply this whole top. Actually, this says, I'm wrong. This one says -2, but it should be -3. 1 second. While I have you here, I'm just going to change it. Okay. Okay. So -3 times positive 2x becomes -6x. -3 times y becomes -3y. -3 times 3 becomes -9. And now I can eliminate because I have an opposite here, but also I have this opposite here. And because there's two opposites, just like previously, we can cancel both of them. And what's left on that side? 0. What's left on this side? -18, because -9 minus -9 becomes -18. Now, does 0 equal -18? I'm going to say no. Having zero money is not the same as owing someone $18. I'd rather have zero money. Okay, so because they are not, it's not true, it's false. And this is when we have no solution. And so if I was to rewrite both of these equations in slope-intercept form, we'd see that they have the same slope, but different y-intercepts. And again, we know this because this is false, and false means no solution. No solution is a set of parallel lines. Okay, our last problem is our word problem. So it says Luke has chickens and pigs on his farm. These 24 animals, so we know that the chickens plus the pigs equals 24. But in all, the animals have 68 legs. How many of each animal does Luke have? So again, C plus P is 24. That's what I got here. C plus P, chickens plus pigs equals 24. And then next, I know that a chicken has 2 legs, a pig has 4 legs, so I'm going to say 2 chickens plus 2 chicken legs plus 4 pig legs equals 68 legs. Okay. And I'm looking for an opposite here. I know that the opposite of 2c is -2c. And the opposite of +4 is -4. So I'm going to use a smaller number and multiply this top by -2. And that will give me -2c, -2p, and -48. -2c, -2p, and -48. Okay. I'm going to cancel my c's. What's left is -2p and no, I'm wrong. 4p, okay, let's start over again. 4p minus 2p is going to be 2p, and 68 minus 48 is 20. So I'm going to solve by dividing both sides by 2, and I'm going to get p equals 10. Now, we could take this and plug it back into this equation, but we also know that there's only 24 animals. So if 10 of them are pigs, then the chickens, there has to be 14, because 10 plus 14 equals 24. So how many animals did they have of each? They had 14 pigs and, sorry, oh my gosh, they have 10 pigs and 14 chickens. Okay, so tonight's homework is going to be 4.3 homework. And if you have any questions or concerns about elimination, please don't hesitate to contact me by email, and then I can show you how to do a problem, and then I'll send it back to you. Hey, are there any... Oh my gosh. Okay. Have an awesome day, guys.